Now, how do switches learn about each other? As mentioned, Bridge Protocol Data Units, or BPDUs, are sent out of all ports on switches by default every 2 seconds when running spanning tree. So switches will learn about each other when they receive BPDUs from other switches on their ports. As an example, in this topology, switch 1 will know that there's a loop because it's receiving a BPDU from switch 2 on port 2 as well as port 3. So BPDUs from a switch with the same bridge ID are received on multiple ports, and thus switch 1 knows that there's a loop between itself and switch 2. In the same way, switch 2 knows that there's a loop because it receives BPDUs from switch 1 on both port 1 and port 3. In other words, it's receiving BPDUs from the same switch on multiple ports, hence there must be a loop. Now, BPDUs contain lots of information, and I'll demonstrate that in a moment. One of the pieces of information that a BPDU contains is the bridge ID of the sending switch. A spanning tree bridge ID is an 8-byte value unique to the switch. It consists once again of a 2-byte priority field and a 6-byte system ID, with the system ID being based on the burnt-in MAC address of the switch. So in other words, the bridge ID consists of the priority 32768 by default in decimal or 8000 in hexadecimal and the MAC address of the switch. That means that the bridge ID is going to be unique in spanning tree. So BPDUs contain information about spanning tree. Switches send BPDUs using their unique MAC address to a destination multicast address of 0180C2000000, or if using per VLAN spanning tree, 01000CCCCCCD. There are 3 kinds of BPDUs: a configuration BPDU, which is used by spanning tree to provide information to switches, a topology change BPDU to tell switches of a change, and an acknowledgement BPDU, which is used to confirm the receipt of a topology change notification. BPDUs are sent by default every 2 seconds once again.